So we're down to 8. Given f of x equals 1 plus root x, what are the domain and range of f of inverse x? Well, there's two ways to do it. I guess the best way is just to think of what's your domain and range of this. Well, range is y is greater than or equal to 1. Domain, x is greater than or equal to 0. So for your inverse, it's going to be the opposite, right? Domain is going to be x greater than or equal to 1. Range, y is greater than or equal to 0, which is C plus 1. Which of the following is an antiderivative of this? That just means integrate. Don't use the 4, right? It has to be monic. So don't let them fool you. 1 over 4, x squared plus a quarter. Think of it like that. 1 over 4, 1 over x squared plus a quarter. Then for integration of tans or inverse tans, you have to remember it's 1 over a inverse tan x over a. That's all I can tell you or remind you of. And then otherwise the answer is 1 over 4 inverse tan x over a. Sorry, I missed it myself as I was doing it. 1 on a is 1 over 2. And then inverse tan, yeah. So then technically 2 over 4. So D. Yeah, D. 2 over 4 is half, and then inverse tan of 2x plus C. So that's 1 over 2 inverse tan 2x. All good? Question 4, that's 1 mark. Getting closer. 6. Maria starts at the origin and walks along all of the vector 2i plus 3j, then walks along all of the vector and finally along all of the vector. How far from the origin is she? How far? What is it actually telling you to do? How far? Sorry? Magnitude is telling you to find the distance. So let's do it. 2i, 3j plus 3 and negative 2 plus 4 and negative 3. First, we've got to work out where she is, right? Because she's moved, like if you think of it in terms of what you were doing, Aya, she's moved 2 to the right, then she moved another 3 to the right, then she moved 4 to the right. Then she moved 3 up, 2 down, 3 down. So we're going to work out where she is. She is now at 2, 5, 9. She's at 9, 1 minus 2. She's there. What's her distance when she's there? Well, her distance is square root of 9 squared plus 2 squared. 81 plus 4, 85, answers B. Done. 5. Happy with that? Just weird saying all of the vector. Anyways. A monic polynomial of degree 4 has one repeated 0 of multiplicity 2 and is divisible by x squared plus x plus 1. Which of the following could be the graph of p of x? A monic polynomial of degree 4, x to the power of 4, has one repeated 0 of multiplicity 2, which means if it's not this guy, it's got to be something like this, right? And is divisible by this, right? Which of the following could be the graph? Well, it has to be x to the power of 4, right? Has a one repeated 0 of multiplicity. How do you know if it's positive or negative? I don't know. Let me think. X minus a leading coefficient is going to be greater than 0, so therefore the delta of that must be less than 0, which means it only has one repeated root. Correct. And therefore my answer would have been either, tossing up between that and that. Good. Okay. So a monic polynomial of degree 4 has one repeated zero of multiplicity 2 and is divisible by x squared plus x plus 1. As I said, it has to be multiplied by x minus a all squared, which means it's always going to be positive. So a is always going to be greater than 0, which means a and b can never work. For you to have another root, or another two roots, what needs to happen to x squared plus x plus 1? It needs to at least be solvable. You can't solve x squared plus x plus 1, so it can't be D, must be C. Does that make sense?
Yes.
X squared plus x plus 1. So the only one you can solve is this guy here, which is right there, at A. Nada, do you get that? Mine is a mark. That's at 4. The vectors A and B are shown. Which diagram below shows the vector V equals A minus B? Okay, to do A minus B, we usually do A, then we add would be that's plus B, but we add the opposite direction, which is that one. Correct? And therefore we get V like that. Do we all agree with my logic there? Yes. Unfortunately, that's none of the answers. Yeah? Do you know which one? D, he's right. How did you know?
Yeah. I just did it like normally, but just rotate yours.
Just rotate mine.
Yeah.
How? Rotate it how? Because even if I rotate it to the left,
no, it's like
my B's pointing to up.
Yeah, but it's gonna have to point the other way to be a minus. Right.
Why is it not A? Yeah, I was thinking why is it not A? Oh wait, A is
no, it would be B
A.
minus. It would be B minus A.
Arrows going the wrong way for A.
Arrows going the wrong way for A.
Isn't it going the way?
So for A saying what? A saying A plus V equals B, which means A minus B equals V. No, equals negative V. Did you get that? That's what this one says. A plus V. That's why you got to learn add head to tail equals the resultant. But look at D now. D says V head to tail, V plus B equals A, which means V equals A minus B. D is the answer. All right, 1 mark, go back. Yay. We're at 3. Number 7. Full screen. All right, you guys know what you've got to do. Did you say guess this?
So my guess would be C.
Oh, guess would be C. 7. Why are you guessing? Is there a reason why? Yeah, I don't think you should guess. I think you should actually sub in numbers. I'm going to start with this 1. What happens at 1 and y is equal to, well, it's becoming flat. It's becoming more vertical, which is good. Let's do this one. This is probably your safest bet. At 1 and 1. this is sloped to the left or to the right? Don't let the arrow fool you. No, to the left. Yeah, so don't let the arrow fool you, because it's this way, isn't it? It's technically like that. So yeah, so that's negative, which is exactly what we wanted as well. Because when you sub in 1, 1, it's negative. So that one's right. At 1, 1, this is right. At 1, 1, this is wrong. At 1, 1, this is technically right as well. So right now we could have only knocked off D. What's another one? What's another one that differentiates these? Well, I guess maybe at x equals 0, y equals to 1. At x equals 0, y is equal to 1. Well, at x equals 0, it should be a little bit more flat, whereas this is not saying that it is flat. It's saying that it's going to become a vertical asymptote, which means it's wrong. What? Yeah. Whereas C is saying it's going to become a vertical asymptote. Can you see how it's approaching like that?
Yes.
Do you get me? So this is approaching this asymptote. That's what it's doing.
Are you saying that x equals 0 and y equals 1?
Yeah. It should be 0.
Isn't it really 0?
Yeah, correct. Whereas this at C, it's showing me that it's approaching this, which means it's not at 0. It's approaching a vertical asymptote, which means the denominator can't equal 0. It's undefined. If y dash equals to 0, it's flat. Which one's flat? Can you see it's all flat? Flat, flat. So definitely the answer is going to be A, but I'm going to try to give you another one somewhere else. Can I give you another one? Here, pick this one. Pick this. Look at this. One's positive, one's negative here. Let's see which one's true. Let's pick -1. -half, -half, and y value half. Go. Should be a positive? Well, only A is positive. B is looking like it's negative. Go. Does that make sense? So it's a bit annoying, as we said last week, but just practice a bit more and more. There's no math to it. 2. 3 multiple choices left. Perms and cons, leave it.
Isn't it?
I'm leaving on purpose just to show you some of you that are not confident with perms and cons. Worst case scenario, can we get a band 6 anyways? Number 9. Ooh. The projection of the vector 6, 7 onto the line y equals 2x is 4, 8. So you're projecting 6, 7 onto that line and it will become a 4 and an 8. The point 6, 7, when it's reflected in the line y equals 2x or point A, what is the position of A? Right. Yeah. You can tell by just looking at it, makes sense to you?
Yeah, because the way I did it was...
Yeah,
6.
2 away, 1 away. Yeah, that's how I do it. So look, but if you can't visualize it, you're good. You're good. Y equals 2x. 6, 7. 6, 7 is somewhere there. As it's projected onto this line, it becomes 4 and 8, which is somewhere there. It's on the line. 4, 8. Does that make sense? 100%?
Yes.
If the point 6, 7 is now reflected somewhere here, where is it going to be? That's what it's asking you. Where is it going to be? Where is A going to be? Well, what we understand is that and that needs to be the same. Right? Because the distance from 6, 7 to my line that's projected needs to be the same distance from my line, that's from my y equals 2x, to this point. So the idea is, how many x values are you away from 6 to 4? 2. So 4, again, you're going to be 2 x values away, which means you're at 2. How many y values are you away from 7 and 8? 1. How many y values are you going to be away from here? Also 1. Does that make sense? 1. And what a 1 to finish off with question 10 of the multiple choice. Oh my god.
To be honest, I guessed it because I was like 6.
Question 10.
This is probably not.
Alright. The quantities P, Q, and R are connected by the related rates. So dr on dt is equal to negative k squared. dp on dt is equal to negative L squared times dr on dt. And then dp on dt is also m squared times dq on dt. They are all non-zero constants. So they are all constants at the end of the day. Which of the following statements is true? The first one, dr on dt, just so we know, is dr on dt, which is less than 0. Dr on dt, which is less than 0. Is that increasing or decreasing?
Decreasing.
Sorry?
Decreasing.
Now, when you sub in that dr on dt into here, what happens to dp on dt? Which means it is? So now we can cross off. dp on dt equals to m squared times dq on dt. Final answer? Is q increasing or is q decreasing? Final answer. Why?
Because the sign has to be positive. Because dp on dt is positive.
100%.
Let's go.
So, didn't we just say that this function, this one right here, didn't we say it's positive? So then this guy here, what's it going to be?
Positive.
Positive. So then positive divided by positive? Oh. Hey!
Yo, we got band 6.
We got band 6
Let's go.
in less than 2 hours.
2 minutes to spare. Legendary.
Not bad, huh? Now you can go back, you can chill out, you can do some perms and comms.
Nah,
You know.
I'll take my band 6 and just sit there.
Yeah, I'm just saying, like, it's fine after this. You're okay. You can go back and you can work on your weaknesses. That if it's that topic. But if you can master calculus, you're fine. All right, let's do this question 8.